All right, so now we're going to talk about tension. Tension force. When a cord or rope pulls on an object, it is said to be under tension, and the force it exerts is called the tension force, Ft. Any object that is hanging or suspended is considered to have tension acting upward. In some cases, tension can be applied in other directions as well. In this case, it's hanging, tension is going up, because if you think about it, the rope here is going up. There's no special formula to find the force of tension. We need to use the force diagrams and net force equations to solve for it, so just like we used force of friction. So a 25-kilogram lamp is hanging from a rope. What is the tension force being supplied by the rope? Well, we know that our mass equals 1d5. And we also can make our free body diagram. So we've got the force of tension up because it's hanging. Mg is always down. And in this case, we would put the acceleration direction. However, since it's just hanging, it's not accelerating. So our A equals 0. So now, to find the force of tension, we always take our Newton's second law, which is sigma F equals ma. And now we plug in our sigma F. Remember, sigma F is the sum of the forces. So now from our diagram, we get Ft minus mg. And the other side equals ma. Now we already said our A is 0. So 0 times anything is going to be 0. That means our Ft minus mg equals 0. And now we're solving for Ft, so we want to get it by itself. So the opposite of subtracting mg is to add it. That cancels out. Now you've got Ft equals mg, and you just have to plug your numbers in. Equals 25 times 9.8. Ft is going to equal 245 newtons. All right, next one. A crane is lifting a 60-kilogram load at a constant velocity. Determine the tension force in the cable. So again, for this one, we've got our mass, which is 60. And it says we have a constant velocity. So remember, when you have a constant velocity, our A is going to be 0 because it's not accelerating, it's staying constant. So now we draw our free body diagram. We've got tension force up because the crane is lifting it up. Mg is always down. And our A equals 0. So again, sigma F equals ma. And we know our forces are going to be Ft minus mg, because they're in opposite directions, equals ma. And since our ma is 0, it's going to be Ft minus mg equals 0. And to get our Ft by itself, just like the last problem, we add mg to both sides, and you've got Ft equals mg. Now you just have to plug your numbers in. So Ft equals 60 times 9.8, which is going to give us 588 newtons. All right, next problem. A 90-kilogram climber, so m equals 90, propels, that means they're going down, from the top of a cliff with an acceleration of 1 meters per second squared. So now we've got that our A is going to be 1. Determine the tension. So if we make our free body diagram, we've got the rope that goes up, so that's Ft. Mg is always down, and in this case, A is going down because that's the direction he's going in. He's going down. So now we've got sigma F equals ma. Now we have to use our diagram. On the left side, we still have Ft minus mg. But now on the right side, since our A is going down, That means our MA needs to be negative, because the A is going to be negative. Now to get the FT by itself, we add mg to both sides. And we get FT equals mg minus MA. That MA was negative. Now all we need to do is plug in our numbers. So FT equals 90 times 9.8 minus 90 times 1. And that gives us F. Now, that gives us FT equals 882 minus 90. So our FT is going to equal 792 newtons. Alrighty. Next one. I want to find a different color. Alright. Next one. A crane lifts a 400 kilogram crate upward with an acceleration of 3 meters per second squared. Determine the tension in the crane. So for this one, we've got that our m equals 400, and our acceleration is 3. And if we draw our free body diagram, mg is always down. In this case, ft is up for our crate, our crane lifting it. In this case, since it's lifting it up, our acceleration is also up. So now we would do sigma f equals ma. And in this case, again, from our diagram, we've got ft minus mg equals ma. And if you notice, we keep it positive because a is going up. It's not going down. If it was going down, it would be negative ma. And now to get our ft by itself, we add our mg. We get ft equals ma plus mg. When we plug our numbers in, that's going to be 400 times 3 plus 400 times 9.8, which will give us 1200 plus 3920. And in the end, we will get 5,120 newtons. That's how you do those tension problems. So now, we're basically doing exactly the same thing in these general problems. So we've got an 1,800 kilogram elevator moves up and down on a cable. Calculate the tension force in the cable for the following cases. So in the first one, it's moving up at a constant speed, and the second one is moving down at a constant speed, and the third one is moving up at a rate of 2.4 meters per second squared, and in part B, it's moving down at the rate of 2.4 meters per second squared. So the first part, talking about constant speed up. So we know our mass is 1,800, and we know our acceleration is 0 because it's constant speed. So now, same thing as before. Diagram, we've got ft up because an elevator has the wire on the top, mg down, and in this case, a equals 0. So same as before, sigma f equals ma. And we would do ft minus mg for our sum of forces equals 0 because our ma is going to be 0. We get our ft by itself, and they're equal to each other. And now we have ft equals, 1800 times 9.8, and our FT will equal 17,640 newtons. If we look on this side, they did the same exact thing, and they got the same answer as we did. So now in this one, they're talking about constant speed down. So this is going to be exactly the same because constant speed means your A will equal 0. So you would start with the same diagram, Ft up, mg down, A equals 0, and you would get the same exact equation, which we can see when we go like that, and it ends up being with the same answer. Now this one is going to be a little different because now it is giving us an acceleration and it's saying it's going up. So we still have that our mass is 1,800, and in this case our acceleration is 2.4. So if we start with our diagram, you've got Ft up for the cable for the elevator, mg down, and our acceleration is going up. So now we would set up sigma F equals ma. Our sigma F is that tension minus mg equals ma, because it's positive, we don't have to change it. And now we just have to move mg to the other side. Ft equals ma plus mg, and plug our numbers in. So 1,800 times 2.4 plus 1,800 times 9.8. 1,800 times 2.4 is going to give us 4,320 plus 1,500 times 9.8 gives us 17,640. And when we add them together, we get that our Ft equals 21,960 units. So now, we see that's the answer. So now part B, they're talking about the same thing, same elevator, now it's going down at the same rate. So we still have our mass is 1,800. Our acceleration is 2.4. But now when we draw our free body diagram, we see that we still have tension up for the wire, and we still have mg down because it's always down. But in this case, A is going down. So now when we set up our sigma F equals ma, our sigma F is still Ft minus mg. But in this case, now we have negative ma because our A is down. So to get our mg by itself, or Ft by itself, I'm sorry, you add mg to both sides. Now you have Ft equals mg because it's positive minus ma because it was negative. And we again would write in our numbers. So 1,800 times 9.8 minus 1,800 times 2.4, which gives us Ft equals 17,640 minus 4,320. Gives us 13,320 newtons. So that's that. So now, problem 2, same thing as problem 1. So you're going to do that one on your own. And it's just basically the same thing, but instead our mass is different and our accelerations are different. But you should be able to solve it on your own.